Hello, welcome to my channel. Now we come to problem number 6, which so far we have covered the projectile motion, determine multiple angles possible for the reach the same target, inclined surface, but we have not yet encountered the combine in flat surface and inclined surface in the same question before. So this problem introduced that. Okay, so this problem, firstly, we look on the statement they're giving us. Okay, they said that the projectile is launched from point A to B with initial velocity of 150 meter per second at an angle of 35 degrees above horizontal line. The projectile reached normally to point B at somewhere in the inclined plane. We call it a slant, for example. It landed on the slant in a certain s distance from the start of the incline to where it landed. So another thing is to tell us the point from point A to the start of incline line, horizontal distance is 950 meter. Okay, now that is all they are giving us. So what they ask us is that distance, the slant, the slope distance, and the flight time of this projectile. Okay, so look at the question. They clearly are giving us something about the y-axis distance. Okay, so A is here, B is here. So that means some value from the horizontal line up to point B should be the uh, s distance time sine 15. Okay, so pull up the common equation for determining the distance in y-axis. Plug in what we know so far. Uh, we know that distance in y-axis should be the uh, distance s times sine of the inclined angle of 15 degrees. So we plug in what we know here, and also we have to distribute the velocity in y-axis, so that be initial velocity times sine 35. Okay, again you can see that the minus sign occur here with the acceleration because it was going against the positive y-axis. Okay, after that we do some mathematical arrangement, and when we will get a simplified form of the equation as shown here. We call it equation 1 with the unknown of t and the distance s. Okay, clearly we cannot solve those values by certain this equation alone. So we look on another thing that we know, which is distance in x-axis of the projectile. So in x-axis, it's simple as always. It doesn't have acceleration in x-axis, so it goes simply by the initial velocity time the flight time. Okay, so plug in what we know, Sx equal to velocity in x-axis plus the time the flight time, and then in distance in x-axis is 950 times a certain distance from here to point B horizontally. So that would be distance s time cos 15 degrees. Okay, so we do a summation here. The total x-axis displacement is 950 plus sine cos 15 degrees equal to 150 meter per second times cos 35, that is distributed in velocity in x-axis times the flight time. Okay, do some arrangement will left us with uh, s equal to 127 times t minus 983. Okay, so equation 1 and 2 are equipped with the two variables. Okay, so two variables, two unknown. We clearly should solve this equation mathematically. So to firstly, I want to determine the distance s. Okay, it's okay if you want to define time first, but for me, distance s should be obtained easily by these two equations solving together. Okay, so firstly, we can clearly see that there's some common terms shown in two equations. So the value s is in the same sign and is stand alone without polynomial, without order constant. It's just s there. Okay, so what if we substitute uh, equation 2 inside equation 1? Okay, we let s equal to this uh, t term. Substitute here, we obtain this polynomial equation. Rearrange it again mathematically. We will left with this simple polynomial equation. Okay, use your favorite calculator, and then we will left with the possible time of two value. First 14, another one minus 5. But we already know time is cannot be in minus, so the actual time travel from A to B is 14. It's the flight time. Then we can answer one thing, that the time equal to 14 seconds. Okay, and then from 1, equation 1, we are using, sorry, for equation 2, we're using this expression, substitute t inside, we guess the inclined distance to be equal to 850 meter. Okay, I apologize for the confusing in this. I meant to say that I determine the time first and then the distance later. But in any case, we obtain the time, the flight time of 14 seconds, inclined distance of 850. Okay, so that will conclude this question. So this question gives us some interesting thing to work on in the inclined surface. Okay, so stay tuned for the next question. What our projectile motion will start solving together again. And again, thank you for watching up to the end. I hope you learn how to solve this question and enjoy understanding the concept of the tutorial I made. Okay. Again, thank you for watching and see you guys on the next one.